So, when I break this down into standard deviations, I've got 1, I've got 2, I've got 3. I've got -1, -2, and -3. And like I said, this makes up 100% of the distribution with the tails going on for infinity. So there's no limits to the parameters. So let's take the first question. And basically I'm wanting to talk about the mean of a normal standard is 500. So 500 and the standard deviation is 10. Now what I've asked is for you to find where 95% of those two values are, and then what are the scores between those two values. So it's pretty easy to do this. So if I know my mean is 500 and I have a standard deviation of 10, I just add 10 to this. So 510, 520, 530. And I'll subtract 10 from this side. So I'll have 490, I'll have 480, and then I'll have 470. So if I ask you what are the values between, or what are the values between -3 and -1, I'd be talking about the area here. So if we go back to that particular slide that I talked about, we know that we have 34, 13, 2.4, I believe it is, and then 0.2 percentage points within this. So if I'm asking, what this area is here, all I would have to do is add 13 plus 2.4. And it's 13 point something. I can't remember exactly what it is. It's in the book. Like I say, each book has its own values. Sometimes it's really weird. So 34.13 in our book, and 13.59, and then 2.15, and then 0.13. So it's a little different in each book. 13.59, and then 2.15, and then 1.13. So all I would have to do if I was asking for these two values is I would just add those up. So 13.59 and 2.15. So I've got 7 and then 5. So I've got, right? Looks right to me. I've got 15.74% of the area between -3 and -1. So between the values of 470 and 490, I have an area of 15.74%. So that's kind of what I'm asking for. That's what I want you to be able to understand when we're talking about these percentages. Another thing that I talked about, like I say, central location, skewness. So let me erase this real quick. Let me talk about skewness. Now, if I have a positive skewed distribution, that means it's not normal. So think of a meat skewer, something like a barbecue skewer. So the pointy end is the thing that you stick through the meat. Think of that as the point of skewness. So if the pointy end of the distribution is facing to the right over here, this is a pointy end, then it's going to be positively skewed. So the majority of my distribution is going to be over here, with extreme scores or outliers that we already talked about are pulling the distribution in a positive way. So I'm going to have a median that's going to split the distribution into two halves. So I've got 50% and 50%. Median splits it into two halves. My mean, however, is going to be pulled in the direction of these extreme scores. So my mean may be way over here, with my median being exactly in the middle, but the extreme scores are pulling the mean in that direction. So a lot of times the mean is not a good indicator of the true average, since it's being pulled in a direction caused by extreme scores. So positive side of the distribution, negative side of the distribution, the pointy end is over here, so it's going to be positively skewed. So if I have a negatively skewed distribution, my pointy end is going to be over here, and the majority of my scores are going to be over here. So it's going to look something like this. It may not look exactly like this, but it's going to be shaped funny, with extreme scores being pulled to the negative side. So this would be negatively skewed. Median, 50%, 50%. My mean is being pulled in this direction, so my mean may be over here somewhere. Never a good idea to use the mean as a measure of central location when you have skewed distributions, because it is not a good indicator of the true average, because it's being pulled in a direction. Let's say that Donald Trump moved to Okmulgee. Now his income would skew the normal income in a positive way, because I don't know how much money he makes, probably, millions of dollars a day, or, I have no idea. It's beyond my understanding, because I don't make that kind of money. So his income would be so different from everybody else's in this community that it would skew the actual average. So the average income, if we had Trump living here, would not be a good indication of the true income of most of the people here. That's why we do not use mean for average income.